This is 4-9 isosceles and equilateral triangles. The first theorem, the isosceles triangle theorem, states if a triangle is isosceles, then the base angles are congruent. The converse of the isosceles triangular theorem would be basically just the opposite. If you have base angles that are congruent, then the triangle is isosceles. And you probably already knew this one, but if you have an equilateral triangle, then all of the angles of that triangle are congruent, and more specifically, they're 60 degrees each. That's the angles, not the sides, remember. Okay, so here's an example of what we would have to do for these isosceles triangle problems. So we have that one of the angles is 48 degrees, but remember, how many angles are in a triangle? 180. So if we used 48 already, then we have 132 left. 132, yep. And so then we divide the 132 by 2, and we'd get 61 for each, 61 degrees each. You could also do this algebraically, where this missing angle is x, and the other missing angle is congruent, so that must also be x. And then we can add everything here and set it equal to 180. X plus 48 is 2x plus 48 equals 180, and we can solve it that way as well. Okay, so here we know that since this is an isosceles triangle, then these base angles, the angles across from the isosceles congruent marks, are congruent. So 6y is congruent to 8y minus 16. So we set them equal to each other to solve. You can pause it and try that. I'll put the answer here for you. So I got y equals 8, and I can plug that back in. Like, for instance, I can plug it into 6y up here, which is 48 degrees, and I can also check by plugging into 8y minus 16. 64 minus 16 is 48. These are examples of what you might see for the equilateral triangle. I'll do one of them for you. So the first example, example A, it's asking us to solve for x, and here's something about x. Well, we know since it's an equilateral triangle that all angles are 60 degrees because they're all congruent. So I can just set this equal to 60 degrees. Someone else said that they could just do that. This is 3x plus 15, that's 3x plus 15, that's 3x plus 15. We could add them all, set them equal to 180. Doesn't matter, you'll get the same answer. So if I set this equal to 60 and start solving, I'd subtract 15 from both sides. Then I would get 3x equals 45, divide both sides by 3, and I get x equals 15. And we can plug that back in to make sure that the angle really does equal 60 degrees.